There are many components in the food industry, but also in home appliances that get contaminated by bacteria. Chemical coatings were developed to prevent the bacterial. Thinking to, for example, Teflon coatings or chemicals that can detach from the surface and can be mixed with the food that we are eating or with the fluids that are in contact with metals. So if we can prevent the attachment of this microorganism on the surface, this can decrease the use of chemicals and the use of pharmaceutical products. TreClean is a project funded by the European Commission under Horizon 2020. And the ambition is to change the behavior of metals and especially reduce contamination by the bacteria to be used for the agri-food industry and for home appliances. Metal surfaces are produced in a mechanical way. If we want to give to them some specific functionalities, we have to start thinking to nature, more to nature than to industry. For example, the surface of the lotus leaf. When the rain is falling on the leaf, we can see the entrapment of hair, micro, and even nanobubbles, and this phenomenon can prevent the attachment of the water on the leaf. So this can promote a self-cleaning effect. This is an important principle that was transferred to metals and to polymers by photonics.
There are two main factors that influence bacterial adhesion. One is wettability, or how well a fluid interacts with the surface, and the other is surface topography, or surface form, which dictates how much contact area there is between a bacterial cell and the surface. If we can tailor these two things, which we can do in a single step with a laser source, then we can reduce how well bacteria stick to the surface.
In particular, we are promoting a state of instability on the surface which can create a pattern of very, very fine ripples that can prevent the bacterial adhesion.
The ripples produced by ultra-short laser pulses are basically just ridges that are separated by about 1 micron or less. So the contact area between the bacterial cells and the surfaces is reduced. It's like standing on a series of needles, so they tend not to attach as much. So the samples that were produced with the laser are submerged in bacterial broth for a certain amount of time, and they are then analysed. The amount of bacterial cells attached to the surface are counted.
What we can see here is the difference between the bacteria that can grow on a surface that is treated with laser, that is this column here, and surface that is not treated with lasers.
One of the main aims of TreClean is to produce these surfaces on large metallic panels. So a large part of the project is upscaling, so using high-power laser sources, extremely fast scanning optics, to be able to perform this in a reasonable time scale on industrial components.
I must say that without the funding of the European Commission under the Horizon 2020 program, these activities would not have had a positive outlook as they have in this moment.